Of very long power cables around the UK. The reason we say national grid because every country has a national grid. In the UK, this power line goes everywhere around the country. So if you consider something like this, for example, a big ring, a lot of power plants. It could be gas, or nuclear or oil power plant. They send their power into the national grid, and there are some users. Yeah, we talked about this. These are the users and producers. But this is a simulation of what is happening. We want to see why it's better to send from the power plants when we generate electricity to the users by low voltage, by high voltage, low current. What is the benefit of sending this if it has very low current and high voltage? We know that this is, for example, something around 400,000 volts or 400 kilovolts. Why on the national grid we have a high voltage?
So you don't lose energy through heat.
You don't lose energy
through the heat from the current.
From heat by the current. Why? Because the power is current times voltage. Yeah? So then you have a high, very huge current here, very huge power. If you have huge power, either current should be very big or voltage should be very big. What is the problem if current is very big?
It's hot.
Because power is also I squared times R. Yeah. If the current is very high, you have a very high amount of waste of energy. So very heat. So high current, high heat is generated. So we try to reduce the current and we try to increase the voltage. This is what you see in this demonstration. So you can come closer, please. Show you the numbers, what is happening here. We have two transformers here. Each of them is 12 and 240. So it can increase the voltage from 12 to 240. This one also from 12 to 240. The first thing we do is transfer it from 12 volt to 12 volt. Yeah, because these two are 12 and 12. So actually we don't use the transformer. It just changes something from here to 12. So when I increase it, it's 3 volt, around 3 volts in the power pack. But this transformer changes it to 12 volt and send it to 12 volts. So what is happening is, here you send directly from 12 to 12 without changing voltage. You don't increase the voltage. What is happening if you don't increase the voltage? This is scenario 1. Scenario 1. From 12 volts directly to 12 volts. It's not high voltage. So what is happening here? You see that how much of power is transferred. This is the power you get from the, upstream of the line. At the beginning of the line, you can see that it's a high power, but here is a lot of power loss. So when it gets to the houses, to the consumers, to the factories, to the schools, nothing is left, because all of that changes into heat. And if you touch it, you can see that it's hot. Right? So this is hot. So actually in this case, you have power loss as heat, because it's low voltage, 12 volts. Scenario 2 that you can test is what about if you change it to 240, because this allows you to change from 12 to 240. So we go from 12 to 240, we transfer at 240, and when you get to the destination, you change it back to 12 to use it. Because we don't want to use high voltage. Turn it back. Again, you produce 12, but you use 12. But you transfer at 240. Okay? What is happening here? So you have high voltage. High voltage transmission. Okay? And see what's happening if you have high voltage transmission. So I disconnect the power, I change it to the other one, which is now 240 and 240 here. Alright, so let's see what happens. If we now increase, so actually the power goes from 12 to 240. That's the power at the beginning. It transfers high voltage here, 240 to 240. You can see that's the power at the destination. So it's a very good efficiency of the power transmission. They are not exactly the same, as you can see. Still we have some power loss here, but much better than the past. And if you touch it, you can see it's not hot. Yeah. Mm-hmm. So that's the benefit. This is exactly what is happening in the national grid. So you can see it with a simple demonstration. What is happening is when they generate electricity, there are some transformers after the power plants increase it to a very high voltage, around 400,000 volts, transmitted all over the UK in the national grid. When it comes to the towns and cities and you want to use it, you drop it and you use it. So there is very less power loss in here. Okay, makes sense? Mm-hmm.